Okay, so we've been presented with this equation and we've effectively been asked to balance the equation. And one of the things that's been specified is that in our final answer, we should only use whole numbers to balance the final equation. So how am I going to approach this? Well, the first thing I'm going to want to do is I'm going to want to audit the number of atoms of each element present on both sides of the equation, both the left hand side and the right hand side. That's going to give me an idea of where the starting point is, and it's going to help. Effectively, the framework produced makes it much easier to resolve the balance issues. So if we do that, so I'm going to do LHS for left hand side, RHS for right hand side, and so I'm going to do H, right, N, and then Ca, O, okay. Okay, so let's start off with auditing the left hand side. So how many hydrogens do we have on the left hand side? Well, we've got one hydrogen here and we've got OH2, so we've got two hydrogens here. So if you add that together, we've got 3 hydrogens on the left hand side, right? And for nitrogens, we've got HNO₃, and we've got no nitrogens here, so that's more or less what that's only 1 nitrogen. And for calcium, we've got CaOH2, so in effect you've only got 1, right? So you've only got 1 Ca, right? And then for oxygen, we've got 3 oxygens here, HNO₃, and then we've got within there we've got OH2, so that's 2 oxygens effectively. So if you add those together, we've got 5, right? So 2 plus 3, so you've got 5 oxygens. If we now do audit of the right hand side, and I would invite you to have a go at auditing that yourself as well. So if you look at the hydrogens, we've got, as you can see, we've got 2 hydrogens. Nitrogens, we've got NO3 2, right? So that's N, effectively N times 2. So we can say we've got 2 nitrogens, and for Ca, CaNO3 2. So, but the Ca is outside of the bracket, so it's just going to be effectively 1 for Ca, right? And then for oxygen, we've got a number of oxygens. So we've got O3, and that's within the brackets, and they've got 2. So that's going to be effectively 3 times 2, that's going to be 6. But that's not the only oxygens, right? We've got an oxygen here, so that either 6 plus 1 is going to be 7 oxygens, okay? Okay, so this is our audit. This is the audit of the equation we were initially presented with. As you can see, we don't have much of a balance. The hydrogens are not balanced, the nitrogens are not balanced, the calciums are balanced, right? And then the oxygens are not balanced, okay? So how am I going to approach this? I think so for me, the first thing I'm actually going to try and at least get some level of balance is I'm going to try and make the nitrogens more balanced, okay? And so how am I going to do that? Well, we've got more on the right hand side than we have got on the left hand side. So what I'm going to focus on doing is actually increasing the nitrogens on the left hand side to be on par with the number of nitrogens on the right hand side. So the way I'm going to do that is, as you can see, the only species where we actually have nitrogens on the left hand side is HNO₃, right? So what I'm going to do is just simply put a 2 in front of that, right? So I'm going to put 2 in front of the nitric acid. So if we write out the equation now, what that looks like after that, and then do an audit, that's effectively going to be 2 HNO₃, right, plus CaOH2, and that produces CaNO₃ 2 plus H2O, okay? And so what I'm going to do is I'm going to effectively audit this new equation we've got, just to give us an idea of what the current state is as far as the balance of things. So if you do that, so left hand side, right hand side. So we changed only the HNO₃ component. So the right hand side aspect of this is going to be exactly the same as it was before, right? So if we just write that out first, so HNCAO, it's going to be exactly the same as it was before, okay? So that's effectively, as you can see, it was 2217. It's going to be the same, so 2217. For the left hand side, this is where we actually modified something. We modified the HNO₃, so that's going to affect the numbers for the hydrogen, the nitrogen, and the oxygen, right? So HNCAO. Now the thing is, the 2 is not in front of a species containing calcium, so we can just put the same number for calcium, so it's going to be 1 still, okay? But everything else is basically going to be a bit different. So for hydrogen, we're going to have 2 hydrogens, and we know from here we've got 2 hydrogens, so that's going to be 2 plus 2, so that's going to be 4, right? In terms of nitrogens, HNO₃ is the only species on the left hand side which contains nitrogen, so that's going to be simply going to be a 2, okay? However, for oxygen, we have 2 oxygens over here, right, from the CaOH2. Now for O3, we're going to have to do 3 times 2, right? So that's going to be 6. So we're going to have to do 6 plus the 2 from here, which is going to be 8, okay? And yeah, so as you can see, now we've got a balance between the nitrogen and a balance between the calcium, but when it comes to the hydrogen and the oxygen, we do not have a balance at this stage, right? So we've got half the number of hydrogens on the left hand side, and we've got we've got 1 less oxygen on the right hand side than the left hand side. How would we resolve this, right? So if you do look at the species on the right hand side, what you can see quite clearly is that H2O contains the 2 species which we're trying to get balanced at the moment. So that would probably be where the opportunity is to try and get this balanced. And if we do look into that, if we put a 2 in front of our H2O, what is going to happen? Well, if we put a 2 in front of our H2O, we would increase the number of hydrogens by 2. If we that 2 would also cause an increase in the oxygens by 1 on the right hand side. And so I'm going to write out that equation and I'm going to do an audit, okay? So but you can kind of see based on visual inspection where that's going to lead us to, right? So effectively that gives us 2 HNO₃ plus CaOH2 produces CaNO₃ 2 plus, and then we got, this is where we put our 2, so we're going to put our 2 in front of the H2O. And if we now audit this again, right, so in this iteration we did not actually change anything on our left hand side. So as far as left hand side goes, it's going to be exactly the same as what we had just written. So it's going to be HNCAO So it's going to be 4, 2, 1, 8. Okay, so literally just what was there before, because we didn't change anything. And for the right hand side, we added a 2 for the in front of the H2O. So this is not going to change the number of Ca, for example. So HNCaO. If we take a look at that. So for the oxygens, actually I'll just start with the hydrogens. Hydrogen, we only have hydrogen in this species, right? The H2O, and you've got 2 of them, so that's going to be 4, right? Now for nitrogen, we have nitrogen here, so it's going to be N. We've only got an N and then times 2, so that's going to be 2, right? And you can already see this is like, it's just balanced effectively on the first 2. For calcium, we only have 1, and so that's going to be a 1, right? And for oxygen, we put the 2 in front of the H2O, so that's going to be 2 times 1, which is going to be 2. But here we've got 3 times 2, which is going to be 6. So we've got 6 from here plus the 2 from here. It's going to give us 8, right? So O is now going to be 8 on the right hand side. And if we now compare the product of our audit on the left hand side and on the right hand side, you can quite clearly see that in effect it's balanced, right? But it's not just that it's balanced, but if we remember the specification, if we remember what was specified in the question, it says please only use whole numbers when balancing the equation. If we actually look, do we have all whole numbers? Yes, you only have 2, obviously, which is an integer, it's a whole number. So this is what we have here is our balanced equation, okay? And I hope you get, I hope you see from that how useful it can be to actually do a careful audit of both sides to make sure you really know where you are and what actually needs more work in terms of changing it to be more closer to being balanced, right? Okay.